I'm so excited to be here. I'm going to tell you about a very new project that's really in its early stages, but I'm excited about it, and I want to share with you some of the basic ideas. So the question that I've been really passionate about recently is this. A lot of people are doing great things with generating code using large language models, but sometimes all these things seem to be able to do is autocomplete. And the question is, can we do better? Can we actually generate an entire software application? So, how good are language models currently at generating code? Well, GitHub, the maker of Copilot, one of the most popular tools, has actually been tracking how much code its programmers, its users, generate automatically. And as of a year ago, it was almost 50%. So it's undoubtedly more now. So programmers love this. And if you look at the accuracy of these tools, at least according to one benchmark, Google's crowdsourced collection of Python programs, it seems that accuracy is getting better and better, and it's over 90% for a wide range of programs. So this seems really impressive and cool, right? However, when you look at the details, what you realize is that all of these examples are essentially on single functions. And if you actually want to build an entire app, it's a completely different story. So if you go and you ask in one of your favorite question and answer forums, can I build an entire app using GPT? The kind of answer you'll get is something like this. It says, well, you can ask, but you're not really going to get there. What you actually have to do is architect the whole app yourself in your head, break it down to little pieces, and then you can get GPT to build the pieces. And even the CEO of GitHub, the maker of Copilot, basically seems to think that this is the future of automatic programming. In an interview he gave, he said the following. He said, the skills of the developer in the future are going to be to figure out how small do I have to go till I reach the point where AI can take over. So obviously, LLMs are going to get better, but I don't believe they're ever going to overcome this fundamental barrier unless something big changes. And I've been interested in software for a long time, and I think what's going to have to change is how we think about software and how we structure it. So I'd like to give you a little flavor of why that's necessary and how I think we can do that restructuring. So let's think about a typical app. So here's Hacker News, right? It's actually a very simple app, and when you look at Hacker News, if you haven't used it before, you can figure it out pretty quickly. And the reason is, like pretty much any other social media app, it's made of things we're completely familiar with. So you figure out eventually that thing at the top is a post, there are comments on the posts, that button in the top right-hand corner marked login is, of course, some session functionality, there's upvoting of posts that ranks them on the home page, there's favoriting, and if we click on a user, we can find this user has so many karma points. Why do we even know what karma points are? Because it's a conventional notion from other websites. So here we have an app which is basically assembled from completely familiar pieces. There's nothing new, right? And in fact, I would argue most social media apps are like this, and maybe most software is like this, right? New things made out of old pieces, right? But that doesn't mean this isn't successful. There are 10 million page views on Hacker News every day, so they're obviously doing something right. So what are they doing right? Well, this is something that Margaret Bowden, in her analysis of creativity, calls combinational creativity. What they basically do is take these familiar elements and put them together in novel ways. And so for Hacker News, there are some slightly weird things. A post, for example, always has a title and either has a URL that you get pointed to, or it has a comment. You can't have both. You can't comment on a post after 2 weeks. You can't edit a comment after 2 hours. You need some amount of karma, 501 points apparently, to be able to downvote a post. And the accumulated effect of all these small tweaks is to create an experience that is very appropriate for a technology Q&A, social media forum like Hacker News. Okay, so let's think about what we would do if we were going to build Hacker News, as good old programmers, in Programming 101 at MIT, right? So we've learned how to do object-oriented programming. How are we going to do it? So let's start. So we're going to create a class for our users. Users have usernames and passwords, appropriate methods for registering users and checking when they log in. We'll make another class for post, right? A post has an author and it has a body and so on. And we have a method, a constructor for creating a new post. Everything looks great, okay? And now let's start thinking about how we're going to add some features. So let's add the ability to upvote and downvote posts. Okay, so maybe what we'll do is we'll add to the instance variables of the post class the set of users who've upvoted and downvoted the post, right? We need to track the users so people don't double vote. And we'll add appropriate methods to do upvoting and downvoting. How about karma points? Well, karma points belong to users, and so we'll throw them into the user class, right? We'll give every user their number of karma points, and we'll have a method for increasing a user's karma and checking that a user has a certain number of karma points, okay? And now what we're going to need to do is we're going to need to use those karma points. So how are we going to do that? Well, for example, inside that downvote method, what we're going to do is we're going to check whether or not the user has enough karma points. So this is completely standard. This is the way that object-oriented programs are written. Likewise, we're going to add commenting. Maybe we're going to treat comments as posts. So a post will have a sequence of posts associated with it that are the comments, and we'll add a method for generating comments and so on. Now, this is a story that we tell our students every day, right? And we're sort of proud of this. There's a lot of nice technology here and a lot of elegance. But actually, this is a disastrous way to write code. And why is it a disaster? Because if we color this code, right, using a different color for each of the functional features, what we find is that we have this rainbow mess in which all the features have been intertwined, right? There's no separation of concerns here. And this is a term, this term separation of concerns. You know, this has been a holy grail in computer science for, I don't know, 30, 40 years since the famous computer scientist Edgar Dijkstra coined this term, right? And this is an absolutely prime example of violation of separation of concerns. In fact, I would argue object-oriented programming is all about violation of separation of concerns. And let's see why. Because if we look at the post class, this post class that we wrote has in it posting, commenting, upvoting, karma. It's all there. And that's a disaster. Why is that a disaster? It means that we've created a class that is completely not reusable. Because if you wanted to build another website, another social media site, and that site had posting, but the posting didn't involve commenting and karma and all these other things, right? You wouldn't be able to use that class, right? So this is a violation of the most fundamental principle of modularity. And secondly, note that the way we wrote this, we've created dependencies between files. So our post class, because it has to check the karma, actually has a call to the user class, right? So what's the consequence of this? It means that you can't build these pieces independently. It means that if you're going to build them with an LLM, for example, the LLM writing the post class would need to know about the user class. And of course, in a small example, this doesn't really matter so much, right? But in a big system, this is a huge problem. So we need to rethink this, and we need to build our software in a completely different way. So here's a simple proposal for how we might do it instead. And the idea is we're simply going to take each of these concerns, the posting, the commenting, the karma, and so on, and we're going to put it in its own module. And I call these modules concepts. And so it's going to look like this. And notice now, the beautiful rainbow coloring has disappeared, right? Because each concept now has its own color, respecting the boundaries of functionality between the different concerns. So the concerns are cleanly separated. And notice we've also got rid of the references between the modules. And one of the things I did here was make these concepts so-called polymorphic, so that comments, for example, the commenting functionality knows there are users, they're sort of things called represented by this variable u, and there are targets of the comments, right? But it doesn't need to know anything about those users or those targets. All it needs to know is about the comments themselves. Now, there are two things you might say, looking at this. You might say, you know, are you crazy, right? You can't rethink software, like, and have people write their software in a completely different way. People have been writing object-oriented programs for years. They're not going to do something different. And indeed, there are two fundamental problems with this structure, the way I've shown it to you. The first problem is that if you look at the state that's now stored, because it's not an object, and because, for example, the comment concept has to maintain the mapping between the comments and their authors, and the comments and their targets, right? That means that we need to have these maps, and these maps need to be bidirectional, right? Which means not only do I need to be able to get from a comment to its author, but I need to be able to get from a target to its comment to ask the question, what are the comments on this post? So that's a problem. However, it turns out we've solved this problem. It's called databases, right? And databases are pretty good at this. It's called doing a join in a database. And so web apps already do this, and it's completely familiar. The other thing you might have noticed is that in order to disentangle the karma from the downvoting, what I actually did was I pulled out the little bit of code that said you can only downvote a post when you have enough karma. That was no longer embedded in one of the modules. In classical software engineering, this is called a mediator. I call it a synchronization between the concepts, right? And again, you might say, how's this going to work? Well, again, it actually turns out that this fits perfectly into the style of programs people are already writing. Because in full-stack web apps, what typically happens is that you have a data layer, and on top of that data layer, you have what are called routes. And the routes basically bind the endpoints, the HTTP endpoints, to the actions by making calls exactly like this. So this structure actually can be translated completely directly into a conventional web app. And the result that you get is a structure like this, which is just like the way many web apps are built, but with one crucial distinction, which is that these concepts, which represent these vertical slices, are actually completely decoupled from one another. And there's no dependencies between them. And that offers a great opportunity. And that opportunity, you won't be surprised to hear, is to build this all with something like GPT. And so I'm going to play the normal kind of game, which is I'm going to take a prompt, and you can use GPT to generate code. But the crucial difference is what the prompts are going to be and what the code's going to be. And so the essential idea is that I'm going to generate code for each of these concepts separately. And the point is that these are completely independent. GPT doesn't need to know from one concept about another, right? We're going to be able to do this with a small context, one at a time. And then what we're going to do is we're going to take a specification of the route, the endpoint, a prompt that the user has written, and we're going to generate code from that. And that code, as you saw on the previous slide, is going to need to use the code from the concepts. Well, how's it going to do that? Well, the way it's going to do that is we're going to use GPT to extract API specifications from the concepts that it just wrote so that it can call those in the route. And then we're going to generate the front end from a front end specification, wrap it all together, and deploy it. So this is the idea that we've been experimenting with. And my student, Abu Talib Namazov, has built a prototype app generator called Codeless that works exactly like this. When you open Codeless, you basically, you see this simple screen, and it tells you already have some concepts preloaded, such as the concept of a user, the concept of a web session. And then what you do is you start creating concepts. So here's a prompt for the karma concept. And the crucial thing to understand is that this is a very brief description of the concept, and it's completely application independent. We're not talking about Hacker News. We're just talking about the idea of karma. And all we said was that a karma has a user and some number of points. You can increase, decrease the number of karma points, and check whether or not an action is allowed. And from that, what GPT will do is generate the source code. It will generate the database schema and access, and all the normal kind of things that are a lot of work when you're actually a real web programmer. The next thing it does is it generates the API specification from that. And here's a thing I always, that's cute about GPT, right? It generates a better API spec than the description we gave of the concept in the first place. Why? Because things like these, karma, comments, and so on, there's a lot of domain-specific knowledge there, that GPT knows about, and it can fill in the details. And so in particular, it's done things like saying that you can't have negative karma, and it bounces when there's negative karma. Okay, so now what we do is we create a route. So for example, we might say we want an endpoint for registering a user, and we write a prompt that just says, register the user and log in. New users start with 1 karma point. That's it. And from that, notice, there's no explicit mention of any concepts or any actions. And what GPT is going to do is look at its specifications of those concepts and generate code from it. So there's the code. And this code, this is what I call the mediator, right? This is the synchronization between the concepts that makes these calls to the actions within the individual concepts. Okay. And so doing that, it turns out you can build Hacker News. And here's some screenshots to show that we actually did it. We called it hack news so as not to infringe on their copyright. We even have that funky feature, who knows why they thought this was useful, that a user can change the color of the top bar. Very, very, very crucial feature. You can do all kinds of elaborate things that you can do in Hacker News, like sorting posts and looking up posts by date and so on. So, to summarize, where are we with this? Well, I'm very excited about this because there are some things that I think are extremely promising. First of all, using this scheme, we're able to cover all the major functionality of Hacker News. We can do flagging and hiding and karma and so on. We can do some of the more intricate things, such as making comments nested and dealing with Hacker News' rather complicated ranking rules by which posts are degraded after they've been flagged or have been around for too long and so on. And we can do all the application-specific details. For example, that you need a certain number of karma points to downvote a post. The amount of prompting required is really minimal. So for this entire application, it's about 1,000 words in total, which was written in about 100 lines. So, very, very much smaller than the code that's generated. And the thing I'm most excited about is that this is generated without any code editing. So you don't give it a prompt and then look at the code and tweak the code. What you do is you give it a prompt, it runs the application for you, and if you don't like the behavior, you revise the prompt. Now, of course, it's not perfect, right? We've got a long way to go on this. First of all, we haven't yet automated the generation of the front end. Abu Talib has designed a very nice reactive DSL and has already made a lot of progress generating the front end, and we're pretty close to doing that. Secondly, there are some aspects in which it's still a little bit too programmery, because of the way that the database queries are done. When you create a post, for example, when you create the post concept, you have to tell it to include an action, get post by IDs, right, which given some set of IDs, produce the post with those identifiers. And there are a couple of other respects in which there are some awkward implementation details that seep in. What we're working on is, first of all, the idea that you could have a catalog of these implemented concepts, so that when you start building something like Hacker News, you don't even need to specify that we need posts and comments, because those have all been done before. So you take those all off the shelf. And those could be peer-reviewed as well, and tested, and security validated. Secondly, the front-end generation that I mentioned. And thirdly, one of my students has this very neat idea that we could build a kind of intent graph that shows all the prompts that you used and how the code was generated from them, and treat those prompts essentially as the new form of a code base. So in closing, 3 ideas. The first is that what I've tried to argue is that modularity is really key, and that all those ideas that we've been thinking about for decades in software engineering, they now matter more than ever. And in particular, I've shown you that if we can disentangle the areas of functionality into completely independent concepts, then we can actually have an LLM generate those concepts completely independently of one another. Secondly, familiarity is really important, right? Note that what we did was we made concepts for things like karma and comments and posts, and those were completely standard. And all the application-specific bits, like how many karma points you needed to downvote a post, those were in the routes. And that separation is very valuable because it means that all that familiar code can rely on the domain knowledge of GPT and can be replayed. And thirdly, here's something I've been thinking about a lot. The Agilistas have been telling us for years, code is king, right? And all those pixie-headed academics at places like MIT who've been telling their students, that design matters and that specification matters. Well, they are wrong, right? Because we know that all that matters is delivering the code, right? Well, I think that actually agile programming is going to have a reckoning, because what we're now discovering is that we have to tell our students, you know what? Lay off on the programming a bit, because GPT is going to do that for you. You really need to be thinking about design and modularity and specification, because that's where your expertise is going to be, and that's where you're going to get leverage. And so to close, a shameless plug for my book, which tells you much more about this idea of concepts and has a little newsletter and all kinds of fun things. Thank you so much.